Hi students, today logarithms. Logarithms you will have in state syllabus. In CBSE syllabus you don't have logarithms, but in some states you will have logarithms, and in Andhra Pradesh and Telangana logarithms are introduced. But it is very important to every student. In chemistry you will have logarithms. In physics also you will have logarithms. Using logarithms, you can find out the magnitude of earthquakes on Richter scale. First, you should understand the definition of logarithms. First, I will take 10 to the power of 1 is 10 only. Using logarithms, log of, this is base. Base will be like this only. And this 10 will come this side. And this is 1. This is the definition of logarithms. First, you should understand what is exponential form and logarithmic form. You can convert exponential form to logarithmic form and logarithmic form to exponential form. I will write this to exponential form. See, you take log of 10 to the base 10 is equal to 1. It can be written as 10 to the power of 1 is equal to 10. 10 to the power of 1 is equal to 10. This is the definition of logarithm. I will take another example. You know 3 to the power of 4 is equal to 81. We will write in logarithmic form. This can be written as log of 81. 81 to the base 3 is equal to 4. And also you can write 3 to the power of 4 is equal to 81. Here base is same. This is called argument. 81 is called argument and this is base. This is equal to 4. I will write 2 cube is equal to 8. It can be written as log of 8 to the base 2 is equal to 3. And this can be written as 2 cube is equal to 8. Vice versa. Like this, 2 cube is equal to 8. And in logarithmic form, log 8 to the base 2 is equal to 3. And I will write the definition. A to the power of x is equal to n. You take a to the power of x is equal to n. In logarithmic form, it can be written as log of base is same. You take n. This is argument to the base a. Base is a is equal to x. A to the power of x is equal to n is exponential form, and log n to the base a is equal to x is logarithmic form. We have some conditions. A is greater than 0 and this a should not be equal to 1, and also n belongs to real numbers. See, I will take some examples so that you can understand about this. You take a note 1. Note 1 is log a to the base a is equal to 1. This is note 1. Log a to the base a is equal to 1. Log 10 to the base 10 is equal to 1. Because a to the power of 1 is equal to a. If you write in exponential form, a to the power of 1 is equal to a. That's why you should remember log a to the base a is equal to 1. Log 10 to the base 10 is equal to 1. Log 100 to the base 100 is equal to 1. Log e to the base e is equal to 1. Like that, you should understand this note. You should note log a to the base a is equal to 1. Now, what is another note? This is note number 2. Say, what is it? This is the definition of logarithm. Now, you should understand the definition. What is the definition? Log n to the base a is equal to x, logarithmic form. You should write in exponential form like this. Now, a is greater than 0 means a is greater than 0 means a should not be equal to minus 1, minus 2, minus 3, like that. N should be greater than 0 means n you take, n is equal to 1 you take. It should be greater than 0. Means log 1 to the base a is equal to 0. Log, you can write like this, log 1 to the base a is equal to 0, because if you write in exponential form, a to the power of 0 is equal to 1. A to the power of 0 is equal to 1. 5 to the power of 0 is equal to 1. See, 5 to the power of base is 5. 5 to the power of 0 is equal to 1. This is n. It should be greater than 0. 5 to the power of 0 is equal to 1. Write in logarithmic form. Log 1 to the base 5 is equal to 0. Means 5 to the power of 0 is equal to 1. That is true. 5 to the power of always a to the power, always remember a to the power of 0 is equal to 1. That's why you always remember log 1 is equal log 1 to the base anything. This is called common logarithm. You will have common logarithm and also natural logarithms. These are common logarithms. Now you see log 1 to the base anything is equal to 0. You have to take note 3. What is note 3? Always remember log 1 to the base anything means 1 to the base 10 is equal to 0. You should remember log a to the base a is equal to 1. Log 10 to the base 10 is equal to 1. Like that, you should remember log 1 to the base 10 is equal to 0. This can be written as 10 to the power of 0 is equal to 1. Now laws of logarithms. You see log xy to the base a is equal to log x to the base a plus log y to the base a. Xy is not equal to x plus y. You know. But in logarithm, log xy is equal to log x plus log y. How to do this expansion? You should understand laws of exponents. What are laws of exponents? A to the power of m into a to the power of n can be written as a to the power of m plus n. A to the power of m by a to the power of n can be written as a to the power of m minus n. These two are very important for us. You take this as p, q and r. What we have to show? P is equal to q plus r. We have to show P is equal to q plus r. Log xy to the base a is equal to p. You can write logarithmic form in exponential form. A to the power of p is equal to xy. This is 1. Now you take this one. Log x to the base a is equal to q. In exponential form, a to the power of q is equal to x. This is number 2. Next you take log y to the base a. Log y to the base a is equal to r. In exponential form, it can be written as a to the power of r is equal to y. This is number 3. Now you take a to the power of p is equal to xy. A to the power of 1 you take. What is 1? A to the power of p is equal to xy. Implies a to the power of p is equal to, what is x here? A to the power of q. What is y? A to the power of r. A to the power of p is equal to a to the power of q into a to the power of r. A to the power of m into a to the power of n can be written as a to the power of m plus n. Like that, this can be written as a to the power of p is equal to a to the power of q plus r. As we got bases are same, you can equate powers. P is equal to q plus r. Now you got p is equal to q plus r. What is p here? See, you got p is equal to q plus r. What is p here? Log xy to the base a. P is log xy to the base a. What is q? Log x to the base a. What is q? Log x to the base a plus. Next, what is r? Here r is there. What is r? Log y to the base a. log y to the base a. As we got log xy is equal to log x plus log y. Log AB can be written as log A plus log B. Log 5 into 10 can be written as log 5 plus log 10. Like that, you should remember this formula. Log x by y to the base A is equal to log x to the base A minus log y to the base A. You take this as P, this is Q, and this is R. See, log x by y to the base A is equal to P. This is logarithmic form. You write in exponential form. This can be written as a to the power of P is equal to x by y. This is number 1. Next, you take log x to the base A is equal to Q. In exponential form, it can be written as a to the power of Q is equal to x. This is number 2. You take this one, log y to the base A is equal to R. In exponential form, it can be written as a to the power of R is equal to y. This is number 3. First you take 1. Here you take 1. A to the power of P is equal to x by y. You take 1. This is number 1. What do you have to show? You have to show P is equal to Q minus R. We have to show P is equal to Q minus R. Means log x by y is equal to log x minus log y. See, you take this one. A to the power of P is equal to x by y. I have taken 1. Say, implies A to the power of P is equal to, what is x here? A to the power of Q by, what is y here? A to the power of R. Implies A to the power of P is equal to A to the power of Q by A to the power of R. Can be written as, this is number 2. A to the power of M by A to the power of N can be written as A to the power of M minus N. That is loss of exponents. This can be written as A to the power of Q minus R. See, same basis. Bases are same. You can equate powers. You can equate P is equal to Q minus R. Implies P is equal to Q minus R. We showed P is equal to Q minus R. What is P here? P is nothing but log x by y to the base A is equal to log x to the base A minus log y to the base A. These are the laws of logarithms. You should remember log xy is equal to log x plus log y, and log x by y can be written as log x minus log y. Log x to the power of m to the base A can be written as m into log x to the base A. See, we have to show this is, you take this is P and this is Q. Don't take this. You keep as it is. We have to show, what we have to show? P is equal to MQ. We have to show P is equal to MQ. You take this is equal to P. Log of x to the power of m to the base A is equal to P. This can be written as, in exponential form, A to the power of P is equal to x to the power of m. This is number 1. Next you take log x to the base A is equal to Q. This can be written as A to the power of Q is equal to x. This is number 2. Now you take A to the power of P is equal to x to the power of m. Now what is x here? X is A to the power of Q whole to the power of m. I wrote, instead of x, I wrote A to the power of Q. As this can be written as, you take this law, A to the power of m whole to the power of n can be written as A to the power of mn. Like that, A to the power of qm, I will write mq. Say, you got A to the power of P, you got A to the power of mq. Implies bases are same, equate powers. P is equal to MQ, as what you got here, P is equal to MQ. What is P here? Log x to the power of m to the base a is equal to, what is m? You take as it is. As it is, you take, what is q? Log x to the base a. Like that, log x to the power of m can be written as, it falls before log mq. Log x to the power of m to the base a can be written as m log x to the base a. I will tell you one example. What is that example? Log 5 to the power of 3 to the base 10. It can be written as 3 log 5 to the base 10. I did not tell you, I want to tell this one. A to the power of log n to the base a is equal to n. We have to prove this is exponential form. You are thinking that this is logarithmic form. No, this is exponential form. This is base and this is power is equal to n. We have to show that this is exponential form. This is exponential form. We have to show a to the power of log n to the base a is equal to n. You take this as p. We have to show that p is equal to n. Now, you write this. This is in exponential form. You write in logarithmic form. Log p to the base a. Base doesn't change. Log p to the base a is equal to log this log n to the base a. Both are equal. Both are same. You see, log p to the base a and log n to the base a. That's why you can equate p is equal to n. What is p? P is nothing but a to the power of log n to the base a is equal to n. As we showed, a to the power of log n to the base a is equal to n. I will tell one example. You take one example so that you can understand. 5 to the power of log 8 to the base 5 is equal to, 5 is there, 5 is there. Here 5 is there, base 5 is there. For log also base 5 is there. You can write directly 8. What is the answer? 5 to the power of log 8 to the base 5 is equal to 8. You see, you will get n. Now, how to draw the graph of log y to the base 2 is equal to x? Writing logarithmic form to exponential form. 2 to the power of x is equal to y. X is domain, this is range. Already you know. Now x is domain and range is f of x. The 2 to the power of x is the image of x under function f. Now you take like this. This is domain. X is domain. This is range. You find, substitute the value of x is equal to, first you take x is equal to 0. Substitute the value of x is equal to 0 here. 2 to the power of 0. What is 2 to the power of 0? 2 to the power of 0 is nothing but 1. 2, instead of x you substitute 1. 2 to the power of 1 is equal to, you will get 2. If you substitute 1, you will get 2. You substitute 2. 2 to the power of 2 is equal to, what is the range? You will get 4. What is the value of y you are getting? 4 you are getting. If you substitute 2 instead of x, you see, this is 2 to the power of, this is 2 to the power of x and this is y. When you substitute 2, you will get 4. Now you substitute minus 1. Instead of x, you substitute minus 1. You are getting 2 to the power of minus 1. 2 to the power of minus 1 means 1 by 2. 1 by 2 means 0.5. Next, you substitute 0.5. You substitute minus 2. Instead of x, you substitute minus 2. 2 to the power of minus 2. 2 to the power of minus 2. You are getting 1 by 4 means 0.25 you are getting. You plot the points on the graph. You will get the graph of log y to the base 2 is equal to x. 2, 4. Where is 2, 4? 2, 4 will be here. This is 2, 4. Next, 1, 2. 1, 2 will be here. This is 1, 2. And 0, 1. Where is 0? 0, 1. This is 0, 1. Next, minus 1 on x-axis, 0.5 on y-axis. Minus 1, 0.5. Minus 1, 0.5 will be here. See, minus 1, 0.5. Next, minus 2, 0.25. Minus 2, 0.25 will be here. You draw the graph. You draw this graph. It is not touching x-axis. You observe these points 2, 4, 1, 2, 0, 1. When domain is decreasing, range is also decreasing. This is approaching to 0. If you take minus 10 to the power of 6, you will get 0.0000 something you will get. But it is approaching to 0. When domain is decreasing, range also decreasing. It approaches to 0, but it doesn't become 0. Like you see the graph, it is approaching to 0. This is the graph of log y to the base 2 is equal to x. Next, applications of logarithms. What are the uses of logarithms in daily life? You can find out the value of pH. And in Richter scale, you can find out the magnitude of earthquake. Many uses are there. It will be useful in chemistry, physics, and in daily life also it will be very useful.